Unreal Engine. Let's get under the hood.
February 2023. A crash overwrote the project with a different project. Not corrupted, replaced, days of recovery. Nothing worked. October 2023. A rigging asset corrupted. It drives the animation system, which drives the character, which drives the game. One file. Months of work unreachable. December 2024, a point release broke visual scripting nodes in blank new projects. Not legacy projects with accumulated complexity. Fresh, empty projects with engine-level failures. By March 2025, asking whether an update will break a project is a routine thread. Clone, backup, then update. Regression anxiety as standard practice. Unreal Engine. The engine that powered the original game in 1998 became the product. Free since 2015 with royalties after a revenue threshold. The most capable real-time engine available and the least forgiving when something goes wrong. The founder started a software company in 1991 while studying at university. Shareware games distributed through mail order and bulletin boards. The company became a game studio in 1992 and moved to North Carolina. The engine built to run a specific game in 1998 became more valuable than the game itself. Each generation expanded the capability and the licensing reach. The fourth generation opened the engine to the public in 2014. In 2015, the engine became free to use with a 5% royalty on gross revenue after the first $1 million in earnings. A battle royale game launched by the company generates enough revenue to subsidize the engine's development. The engine exists at its current pricing partly because the game funds what licensing alone would not. The fifth generation launched in 2022 with dynamic global illumination and virtualized geometry that changed what real-time graphics could achieve. In 2023, a competitor's pricing decision caused developers to seek alternatives. The engine's profile accelerated. The same year, the company laid off over 800 employees. The founder stated they had been spending more than they earned. Additional reductions followed in 2026. The community asks what happens to the engine if the game that funds it declines. The question has no comfortable answer. The version update cluster across 2024 and 2025 documents the regression pattern. The 5.4 release produced performance collapse for users who upgraded existing projects. Frame rate dropped after the upgrade with no changes to the project content. A point release within the same version prevented a user from opening their project at all. The same point release broke visual scripting macro nodes in fresh projects with no existing data. A new empty project in the following version triggered restore failure errors that persisted after reinstalling the engine entirely. The community thread asking whether to admit that the fifth generation has been a performance disappointment gathered significant engagement. The crash data loss incidents are the more severe category. The February 2023 crash that replaced one project with another is a failure mode unique in the research across every comparison on this channel. Not corruption, substitution. The October 2023 rigging asset corruption is severe because of the dependency chain. The rigging system connects to the animation system, which connects to the character, which connects to the game logic. Corruption at the rigging layer propagates damage across every system that depends on it. Months of work become unreachable through a single corrupted asset. March 2026. A solo developer posted that the engine crashed during a heavy texture load and they felt like quitting. The post is short, the feeling is specific. Someone who invested significant time learning one of the most complex tools in the industry, and the tool failed at a moment that made them question the investment. The engine's complexity means the learning investment is substantial. A crash that destroys that investment's output carries emotional weight the technical recovery advice does not address. The product, when it works, provides capabilities no other tool in this comparison matches for real-time interactive output. Dynamic global illumination that responds to scene changes without pre-computation. Virtualized geometry that eliminates manual level of detail workflows and allows film quality assets in real-time scenes. Digital human creation at a quality level that was a specialist skill 3 years ago. A visual scripting system that provides the fastest interactive prototype path in professional game development. Physics and destruction simulation integrated into the engine. virtual production workflows for in-camera visual effects using display volume stages that are the industry standard for film and broadcast. The complexity ceiling is the real limitation for smaller teams. The engine's architecture surface area is enormous. A solo developer or small team building a project in this engine needs to understand rendering pipelines, asset management, scripting systems, physics configuration, and platform deployment at a depth that no other tool in this comparison demands. The tools earlier in this comparison create three-dimensional content. This tool runs three-dimensional content in real time. The difference in scope creates a difference in complexity that is structural rather than a quality failing. Source control is not optional with this engine, it is mandatory. The project file structure, the binary asset format, and the dependency chains between assets mean that recovering from a crash or a bad update without version control ranges from difficult to impossible. The community advice to clone before updating exists because the alternative is potentially losing the project entirely. Someone building a game or interactive experience where the visual ceiling and real-time performance matter more than development speed should use this engine. The capabilities in lighting, geometry, character creation, and virtual production are unmatched. The team must have the technical depth to manage the complexity. A solo developer can build in this engine. Whether they should depends on whether the visual output requirement justifies the learning investment and the crash risk the engine carries. Someone building a smaller game where visual fidelity is not the primary differentiator should evaluate the open source engine later in this comparison instead. The complexity cost of this engine is only justified when the output requires what simpler tools cannot achieve. For a two-dimensional game, a stylized three-dimensional game, or a project where gameplay matters more than graphics, the complexity overhead is a cost without a corresponding benefit. Someone evaluating the engine after the competitor's pricing decision in 2023 should understand that the enthusiasm cooled as the complexity reality settled in. Switching from a simpler engine to this one, because of licensing frustration, introduces a capability upgrade and a complexity upgrade simultaneously. The licensing frustration was real. The complexity cost of the alternative is also real. The evaluation should weigh both. Someone concerned about the layoffs and the long-term sustainability should consider the revenue model. The engine is subsidized by the game. The game remains among the most played in the world. The royalty model generates revenue from commercially successful projects. The engine's existence does not depend on a single revenue stream. The concern is legitimate. The risk is lower than the community anxiety suggests, but higher than a self-sustaining licensing model would carry. The founder who started writing shareware games in 1991 and built an engine for a specific game. In 1998, created the most significant real-time development platform in the industry. The engine survived 4 generations of graphics hardware, a shift from paid licensing to free with royalties, and a subsidy model that depends on a single game's continued success. The crashes overwrite projects, the updates break blank templates, the regression anxiety is standard practice, the rigging corruption propagates through dependency chains, source control is mandatory. The learning curve is the steepest in this comparison. And for the team whose output requires what only this engine provides, no alternative matches it. The power is real. The risk of using it is also real. The engine does not forgive mistakes at the scale it operates. For the user whose goal is the highest visual ceiling in real-time interactive output, the engine delivers that ceiling. The discipline of protecting the work built under that ceiling is the cost the free license does not include.